Welcome viewers. In this video we will see the transformation and condition for reciprocal of a two-port network for a inverse transmission parameter A dash, B dash, C dash and D dash. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In a two-port network there are various parameters are available. In this video we are going to express the transmission parameters for in terms of other parameters, transformation from one parameter to another parameter in terms of inverse transmission parameter, and also condition for reciprocal. So we know that transmission parameters available and inverse transmission parameters are available. A, B, C, D is the transmission parameter. A dash, B dash, C dash, D dash is the inverse transmission parameters. These parameters are normally used for designing the transmission line. Similarly, we have other parameters are available. Before going to the transformation, we will see the notation for the A dash, B dash, C dash and D dash. This A dash is nothing but V2 by V1, open circuit voltage gain. So both are voltage, so it is a voltage gain. The output port is open circuited, so open circuit voltage gain. C dash is I2 by V1. Here also open circuited, so I by V, so there is admittance, transfer admittance, secondary current and output current and input voltage, so that transfer admittance, open circuit transfer admittance. First two parameter refer open circuit, the remaining two parameter will refer the short circuit. B dash V2 by I1, here V by I, so impedance, output port voltage and input port current, so the transfer impedance, and short circuit transfer impedance. D dash is I2 by I1, minus I2 by I1, here also minus, so both are current, output current by input current, so current gain, short circuit current gain. First two parameters A dash, C dash refer open circuit voltage gain and transfer admittance. B dash and D dash refer short circuit, the port is short circuited. One is transfer impedance, another one current gain, short circuit current gain. Similarly, the delta T dash refer the determinant of the inverse transmission matrix, right? So here we are going to express all the parameter in terms of inverse transmission parameter. So this first we will see this, what is the inverse transmission parameter, A dash, B dash, C dash, D dash. So this is the matrix. The determinant of this matrix is delta T dash. Now we'll see this parameter one by one. First we will see the Z parameter. Z parameter, we know that it is a open circuit impedance parameter. Voltages are expressed in terms of current. D dash by C dash, 1 divided by C dash. Delta T dash divided by C dash, A dash divided by C dash. So in the denominator, so is same term is there, C dash, only numerator is changing. So this Z parameter, the equivalent A dash, B dash parameter is given. Then Y parameter, short circuit admittance parameter, output port is short circuited. Current is expressed in terms of voltage. A dash by B dash, minus 1 by B dash. Delta T dash divided by B dash, B dash by delta T dash, right? So here this three terms is the P dash, one term is delta T dash. So this is the short circuit admittance parameter. Then we'll see the transmission parameters A, B, C, D. So they are inverse transmission parameter. So this one transmission parameter. D dash divided by delta T dash, B dash divided by delta T dash, C dash divided by delta T dash, A dash divided by delta T dash. So the denominator is same term, delta T dash is available, numerator is changing. Then this is the normal ABCD, A dash, B dash, C dash, inverse transmission parameter. So another two parameters available, hybrid and inverse hybrid parameters. So what is hybrid parameter? In Z parameter, voltage expressed in terms of current. In Y parameter, current expressed in terms of voltage. But in hybrid, both are available. For example, V1 and I2. Input voltage and output current is expressed in terms of V2 I1. Output voltage and input current. Both are mixing. So that's called a hybrid parameter. So what is the equivalent? B dash by A dash. 1 divided by A dash. Delta T dash divided by A dash. C dash divided by A dash. So the denominator is same term is there, A dash. Then inverse hybrid parameter, C dash by D dash minus 1 by D dash, delta T dash divided by D dash, B dash divided by D dash. So the D dash available in the denominator for all the term. So this is the equivalent, transmission parameter equivalent. Then what is the reciprocal condition? Delta T dash equal to 1. If delta T dash is 1, then the port is reciprocal. So in this video we discussed the transformation and condition for reciprocal of a two-port network parameters in terms of inverse transmission parameter A dash, B dash, C dash and D dash. We discussed Z parameter, Y parameter, ABCD parameter, hybrid H parameter, inverse hybrid G parameter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.